Hello, and welcome to our What's New presentation for the 2019.1 Vivado release. For this quick take video, I'll start by discussing the high-level enhancements to Vivado, including OS support, install and licensing, and IDE improvements. Then, I'll cover improvements to SysGen, Model Composer, IPI, and our own Xilinx IP. Next, I'll discuss the details of synthesis, implementation, and power, and I'll finish up with simulation and debug. Let's start with our high-level enhancements to OS support, install, and licensing, and IDE. In terms of our OS support roadmap, you can see where we sit with our tools for 2019.1. Going forward, we intend to extend our Ubuntu support across the board. We will also fully support Windows 10 for our software development tools.
On the device side, we want to note that there are multiple devices that are production ready. These include some new space-grade devices, some HBM devices, and a few others. For the specifics, I'd refer you to UG973.
In 2019.1, we're introducing a new command line-based web installer. The installer enables a complete install via the command line and authenticates using a secure token mechanism. We have also enabled an option by default to optimize disk usage. All duplicate files are removed and the disk image post-install is significantly reduced. On the licensing front, we are providing free ISE licenses for any customer with a valid Xilinx licensing account. We're also discontinuing offering installing DVDs for all Vivado and ISE software. In 2019.1, we're enabling a new encryption feature for custom IP blocks. By enabling the Xilinx schematic visibility right during encryption of your IP, the contents of that IP will be hidden from the schematic and the hierarchy views. For more information about this feature, please refer to UG1118. As part of our regular security update in 2019.1, we've changed the Vivado public key. If you're encrypting your IP, please use the latest public key for encrypting your sources. It's located in the Data Pub Key folder. For the GUI, there are a few minor updates. For the dashboard feature that was released in 2018.3, we've added the ability to automatically add new runs to the widget. Secondly, with respect to report strategies, we've added the ability to save existing strategies to new strategies using the disk icon. Let's talk about the improvements we've made to SysGen, Model Composer, IPI, and cover some of the new features in our Xilinx IP. For a system generator, we are introducing two new super sample rate blocks. The Vector Assert and the Vector Relational blocks support all Xilinx devices, including the Zynq UltraScale Plus RF SoC. The Vector Assert block will trigger if any element in the vector is 0 or not, and the Vector Relational block implements a comparator between the two input vectors. If you want to learn more about super sample rate blocks, please refer to the System Generator User Guide. Switching to Model Composer. Model Composer supports 3 new blocks to assist you with your signal processing applications: an FFT, an IFFT, and an FIR filter. We've also expanded the list of blocks that support throughput control, introduced in 2018.3. For these blocks, you define the throughput requirement and will provide the necessary parallelism to meet that requirement. The key here is that this is done without any structural changes to your design. In 2019.1, the XMC import function can assist you with creating custom source blocks for your design. Next, we've improved support for complex types in C and C++. In particular, we've added support for HLS X-complex types, extending the standard complex type library. To finish up on Model Composer, we've expanded support for streaming data blocks, including the matrix multiply, submatrix, delay, and several more. We've improved support for the row matrix n by 1 and the column matrix 1 by n dimensions. Internally, these have shown improved performance. Like System Generator, we continue to support 3 versions of MATLAB, and if you'd like to learn more specifics, I would refer you to the web page listed here. There are a few IPI improvements worth noting in this release. First, we've added an option to annotate the functionality of the slice, the concat, and the constant blocks to the canvas. This eliminates the need to recustomize the IP to understand their function. Behind the BD settings gear, you will see the options to enable, disable, and evaluate the annotations to the canvas. In 2019.1, we're also introducing GUI support for the board store. You can download the latest third-party boards for use in Vivado with a single click of a button. This feature is accessible from the Tools menu or while choosing a board in the new Project Wizard. Let me share with you a few highlights from our Xilinx IP subsystems. On the wired side, we have a new 50 gig KP4 Reed-Solomon forward error correction algorithm. We've also added a size-optimized stat counter for the 1025 gig, 4050 gig, and our integrated 100 gig Ethernet solutions in our UltraScale and UltraScale Plus families. On the wireless side, for the Radio over Ethernet framer IP, we've added Zinc support. The eCPRI has a 50 gigabit per second bandwidth, while the ORAN has 100 gigabit per second internal bandwidth. For audio and video, we've added a new MIPI camera serial interface receive to CSI transmit simulation design. And finally, for storage, memory, and PCIe, we're working on a few pre-production IP, but nothing new for general release. Moving on to RTL synthesis, implementation, and power. On the synthesis side, we've added support for the following VHDL 2008 constructs: generics and packages, generic types and entities, and functions and generics. Also in 2019.1, incremental synthesis can be applied to runs manually or using a new automated flow that takes the results from the previous runs. For SSI devices, automatic SLR crossing registers are now enabled to boost performance and reduce variation in QOR. There's also a new AXI Reg Slice IP that is enabled for all UltraScale and UltraScale Plus devices that maintains high speed and automatically inserts pipe stages. Also, versus 2018.3, we have improved FizzOpt of high fan-out nets, as well as improved report methodology runtimes for designs with many timing exceptions. In 2019.1, we've added new metrics that visualize interconnect density and congestion levels. It also shows post-placement estimated congestion versus the actual congestion seen post-routing. For report QR suggestions, we've created suggestion objects that replace the XDC and Tickle suggestion files. As a result, the flow automatically applies the suggestions at the correct phase in the design, and you can export or import the suggestions using write QR suggestions or read QR suggestions. Finally, suggestions are more tightly coupled with report QR assessment. Report RAM utilization has also been overhauled to provide comprehensive UltraRAM and block RAM array data. The report also uses new statistics to analyze sparseness and critical timing paths. For power analysis, we've improved XPE for Zinc UltraScale Plus RFSoC Gen 2 and Gen 3 devices. We've also included an HBM wizard for Vertex UltraScale Plus devices. You can simply enter the system-level HBM configuration parameters, and the wizard automatically generates the low-level entries. Finally, let's cover the improvements for simulation and debug. A few things that we've added for the Vivado Simulator. On the system Verilog side, we've added the functional coverage and report generation. This enhances constraint randomization and supports assertions on properties and sequences in concurrent regions. Secondly, in XSIM, we've added the protocol instances window. All AXI interfaces in the design are included in this window by default. You can also add these interfaces to the waveform window by marking the AXI buses for simulation in the IPI block diagram. Using this feature will allow you to see the transactions on the AXI bus as opposed to the lower level details of the protocol. The GTM transceiver in the UltraScale Plus devices support line rates between 9.8 gigabits per second and 58 gigabits per second, using PAM4 and NRZ modulations. In 2019.1, the iBert design for the GTM and the Vivado Serial I/O Analyzer now support these capabilities and provide new plotting features for the iSlicer, histograms, and signal-to-noise ratio information for each different link. In addition, there's forward error correction support for the PAM4 and 160-bit data width mode and the internal PRBS patterns. There's no FEC supported for NRZ. The Vivado Logic Analyzer now offers the bus plot viewer. This is a useful debug capability in debugging DSP and RF applications and allows users to plot different graphs based on the probe values versus time or samples, as well as other probe data. The viewer lets you select any signal for the X and the Y axes, as well as plotting multiple graphs on the same plot.
The RF analyzer for the Zinc UltraScale Plus RFSoC is available in 2019.1.
The RF analyzer is similar in concept to the iBert debug tool. It is primarily used on customer boards to help understand the performance of the board in high-frequency applications. The RF analyzer uses the same basic GUI as the RFSoC evaluation tool and provides many of the same features. However, the primary difference is that the RF analyzer is board independent. Since it does not note about the specific board implementation, it does not support DDR RAM buffers. Instead, BRAM buffers are used and are limited in size. Users must also configure an external PLL if the board includes such. The tool communicates between the host PC and the consumer board via JTAG. There are also new memory debug capabilities in Vivado 2019.1 that enable monitoring of HBM device status and performance registers. The debug dashboard shows calibration status and static temperature for HBM memory modules. In addition, you can see various throughput information and monitor activity of different channels.
To summarize, Vivado 2019.1 contains a variety of new features throughout the entire tool. To reiterate the highlights, we have a new command line-based web installer with automatic authentication. We've added support for a bunch of new VHDL 2008 synthesis constructs, and we've integrated GitHub support to download and install third-party boards in Vivado. On the implementation and time enclosure front, we've added a new graphical congestion metrics, improved QR suggestions, and have made decent progress on solving inter-SLR timing paths. Finally, for the debug, we have a whole host of new viewers including iBert GTM, an RF analyzer, the HBM monitor, and an integrated bus plot viewer. For more details, please take a look at the release notes in UG 973. And more importantly, you can download the latest version of Vivado at www.xilinx.com/download. Thank you very much, and we hope you enjoy the new software.